right now. And George, it is all you.
All right, let me get out of this guy's eBay store real quick. Okay, so I gotta share my screen. Let me get back to that. Do that one. Okay, we are going to do sub-element 4 tonight. And I think I just shared the wrong screen. I wanted to share it as a full presentation, but as long as everybody can see it, I guess we're okay.
Yeah, I can see it just fine.
Okay. Some of this I'm going to struggle with, guys. I'm not going to lie to you. Some of it's a little over my head. So some, a couple of these questions, I'm just going to be reading the answer and not really be much help in terms of an explanation, especially on the more technical ones. So if there are questions, I may need a lifeline. But here we go.
I mean, just stop us and, shout the questions out and I'll answer whatever I can. And, we've got some talented folks on. Gene's very knowledgeable about a lot of this stuff. And I'm pretty sure Mike is as well. So, let's go at it.
All right, cool. A1, which of the following limits the highest frequency signal that can be accurately displayed on a digital oscilloscope? That'd be the sampling rate of the ADC, the analog to digital converter. Question 2, which of the following parameters does a spectrum analyzer display on the vertical and horizontal axes? And that's the amplitude and frequency, the RF amplitude and frequency. Which of the following test instruments is used to display spurious signals and or intermodulation distortion products generated by a single sideband transmitter? And that is a spectrum analyzer. How is the compensation of an oscilloscope probe typically adjusted? And you look at the square wave and make sure that the squares are all square, and adjust it until the horizontal and vertical lines are both flat. What is the purpose of the prescaler function on a frequency counter? It divides a higher frequency signal and lowers it so that a low frequency counter can display the input frequency. Question 6, what is the effect of aliasing on a digital oscilloscope caused by setting the time base too slow? And it's a false jittery low frequency version. The signal is displayed because the sample rate just can't keep up with the frequency of the input. Which of the following is an advantage of using an antenna analyzer compared to an SWR bridge to measure antenna SWR? Antenna analyzers don't need an external RF source. And similarly, which of the following measures SWR? An antenna analyzer. Which of the following is good practice when using an oscilloscope probe? Keep the signal ground connection of the probe as short as possible. And then referencing that photo, which of the following displays multiple digital signal states simultaneously? That's a logic analyzer. Let's look at different bits there. How should an antenna analyzer be connected when measuring antenna resonance and feed point impedance? Connect the antenna feed line directly to the analyzer's connector. And there's a good note about getting rid of static charge in the line. All right, section B. Which of the following factors most affects the accuracy of a frequency counter? And it's time-based accuracy. Just like in PC circuits, I guess everything is geared off the clock, timing-wise. What is the significance of voltmeter sensitivity expressed in ohms per volt? The answer is the full scale reading, the voltmeter multiplied by its ohms per volt rating will indicate the input impedance of the voltmeter. And if you pay attention to the units here, this is obviously the right answer because you have volts times ohms per volt. So the volts cancel out and you're left with ohms equals ohms, the impedance of the voltmeter in ohms. Which S parameter is equivalent to forward gain? And that's S21. Which S parameter represents input port return loss or reflection coefficient equivalent to VSWR, and that's S11. Question 5, what 3 test loads are used to calibrate an RF vector network analyzer? And that is a short circuit, an open circuit, and 50 ohms. How much power is being absorbed by the load when a directional power meter connected between a transmitter and a terminating load reads 100 watts forward power and 25 watts reflected power? And the answer is just the difference of those two things in 75 watts. What do the subscripts of S parameters represent? And those stand for the port or ports at which the measurement is being made. Which of the following can be used to measure the Q of a series tuned circuit? And the answer is the bandwidth of the circuit's frequency response. What is indicated if the current reading on an RF ammeter is placed in series with the antenna feed line of a transmitter increases as the transmitter is tuned to resonance? The answer is there's more power going into the antenna. And if power is voltage times current, and voltage is current and impedance, and so the impedance is fixed. So the only thing changing on the right hand side is voltage, and so if that's going up, the power has to go up. Which of the following methods measures intermodulation distortion in a single sideband transmitter? Modulate the transmitter using 2 audio frequency signals having non-harmonically related frequencies. Observe the RF output with a spectrum analyzer. And one of my study guides just said, look for the answer that mentions audio and spectrum analyzer. That's the only answer that has both of those components. Which of the following could be measured with a vector network analyzer? And it's all of these: input impedance, output impedance, and reflection coefficient. All right, part C. This is where my head's going to explode about halfway into this. What is an effect of excess phase noise in a receiver's local oscillator? And it can combine with strong signals on nearby frequencies to generate interference. And and as this says, obscure that weaker signal. Which of the following receiver circuits can be effective in eliminating interference from strong out-of-band signals? And that is a front-end filter or pre-selector. What is the term for the suppression in an FM receiver of one signal by another stronger signal on the same frequency? And that is the capture effect. What is the noise figure of a receiver? It's the ratio in dB of the noise generated by the receiver to the theoretical minimum noise. What does a receiver noise floor of -174 dBm represent? And that is the theoretical noise in a 1 Hertz bandwidth at the input of a perfect receiver at room temperature of 62 degrees Fahrenheit. A CW receiver with the gain control off has an equivalent input noise power density of -174 dBm per hertz, what would the level of an unmodulated carrier input to this receiver what would be the level of an unmodulated carrier input to this receiver that would yield an audio output signal to noise ratio of 0 dB in a 400 hertz noise bandwidth? That's when I seriously considered dropping out of this class.
Yeah, this is one of those where you're going to need your calculator.
Yeah. I stared at a solution to this for a while and almost got where I was really comfortable with it, but I'm still not quite there with it. Chris, correct me if I'm wrong, but the key to the solution here is that with signal to noise of 0 dB, it's a 1-to-1 ratio. So the formula would be 10 log of 400 over the one is coming from, because it's 0 dB SNR, right?
Correct. Yes.
Okay. So as long as we can kind of remember that, if you take and then you have to add that to the original power density, and you get -147.9.
Correct. Yes.
Okay. What does the MDS of a receiver represent? That's the minimum discernible signal. Question 8, an SDR receiver is overloaded when input signals exceed what level? And that's the reference voltage of the analog to digital converter. The reference voltage is the highest voltage it can work on. Which of the following choices is a good reason for selecting a high frequency for the design of the intermediate frequency in a super heterodyne HF or VHF communications receiver? And the answer is easier for front-end circuitry to eliminate image responses. What is an advantage of having a variety of receiver IF bandwidths from which to select? And that's because you can, the receive bandwidth can be set to match the modulation bandwidth, maximizing SNR ratio and minimizing interference. Why can an attenuator be used to reduce receiver overload on the lower frequency HF bands with little or no impact on signal to noise ratio? And that's because the atmospheric noise is generally greater than internally generated noise even after attenuation. Which of the following has the largest effect on an SDR receiver's dynamic range? And it's the converter's sample width in bits, the analog to digital converter. How does a narrowband roofing filter affect receiver performance? It improves the dynamic range by attenuating strong signals near the receive frequency. What transmit frequency might generate an image response signal in a receiver tuned to 14.3 megahertz and that uses a 455 kilohertz intermediate frequency? I found an explanation in another study guide that that helped. I think this was it. Image response signal. Oh no, sorry. I was on a different question on my notebook. I don't have a good explanation for this one. Chris, is there anything you can add to this?
I don't really have a whole lot to add to it.
I know, I think I read that, so the, let's see, you start at 14.3, and then you're adding 455 twice, I believe. And that's 755. And then
Right, so if you add 455,
14,755 and another 455 should be that 15,210.
correct, yes.
So I guess the will generate. Yeah, there was a formula from earlier on that I had written down. The image response signal is equal to the tuned frequency plus or minus 2 times the intermediate frequency, and it seems to be very similar to this setup, but I'm a little lost as to how. So let's keep going. All right. What is reciprocal mixing? Local oscillator phase noise mixing with adjacent strong signals to create interference to desired signals. Section D. What is meant by the blocking dynamic range of a receiver? And that's the difference in dB between the noise floor and the level of an incoming signal that will cause 1 dB of gain compression. The Kessler video, one of the Kessler videos has a good diagram showing this, and I think it's actually out of the book, out of the ARRL book. Which of the following describes problems caused by poor dynamic range in a receiver? Spurious signals caused by cross modulation and desensitization from strong adjacent signals. How can intermodulation interference between two repeaters occur? When the repeaters are in close proximity and the signals mix in the final amplifier of one or both transmitters. And the solution is to use a circulator, which the next question is about as well. Which of the following may reduce or eliminate intermodulation interference in a repeater caused by another transmitter operating in close proximity? A properly terminated circulator at the output of the repeater's transmitter. And Kessler does a good job of explaining this too. His videos are pretty good on this section.
Yeah, the circulator, it's basically, you know, like a one-way valve
Like a
where
traffic.
the signal can go only in one direction.
Yeah. Question 5, what transmitter frequencies would cause an intermodulation product signal in a receiver tuned to 146.7 megahertz when a nearby station transmits on 146.52 megahertz? And there's a typo in the explanation down here. The answer is correct, but there's a typo in the explanation. And I did, let's see. Did y'all just switch over to a Word document on my screen?
I don't
No.
see it. No.
Okay. Well, let's see. Hold on. Well, shoot, I don't know how to change what app I'm sharing.
Stop sharing and then you can reshare.
Oh, gotcha. Okay. Stand by. Okay. Okay. So for the question, the two formulas that are used is the intermodulation product is there's two different formulas. You got your two frequencies, and one formula is 2F1 minus F2, the other is 2F2 minus F1. So the way the question's set up, they give you the intermodulation product signal, and they give you another frequency. We'll just call that F1. Then you just rearrange the formulas to solve for F2, plug the numbers in, and those are the ones, that's the results you get. You'll need a calculator, but if you can remember these two little formulas, that seems like a pretty simple way to get this one. Okay. All right, question 6. What is the term for spurious signals generated by the combination of 2 or more signals in a nonlinear device or circuit? And that is intermodulation, what we were just talking about. Which of the following reduces the likelihood of receiver desensitization? Decrease the RF bandwidth of the receiver. Eliminating those nearby interfering signals. Question 8, what causes intermodulation in an electronic circuit? And the answer is nonlinear circuits or devices. What is the purpose of the pre-selector in a communications receiver? And that is to increase the rejection of signals outside the desired band. What does a third order intercept level of 40 dBm mean with respect to receiver performance? And a pair of those signals will theoretically generate a third order intermodulation product that has the same output amplitude as either of the input signals. Question 11, why are odd ordered intermodulation products created within a receiver of particular interest compared to other products? And that's because those are likely to be within the band. Signals in the band of interest are also likely to be within the band. What is the term for the reduction in receiver sensitivity caused by a strong signal near the received frequency? And that is desensitization. All right, last section. What problem can occur when using an automatic notch filter to remove interfering carriers while receiving CW signals? And you might remove the CW signal itself. Which of the following types of noise can often be reduced with a digital signal processing noise filter? And it's all of them. Broadband white noise, ignition noise, and power line noise. Which of the following signals might a receiver noise blanker be able to remove from desired signals? And the answer says signals that appear across a wide bandwidth. I actually have a question about this one, because at the end of the explanation, it says the noise blanker is only effective on impulse type noise, such as whatever, and cannot improve performance on wideband noise. Signals that appear across a wide bandwidth would then not be considered wide band noise.
Yeah, that is a little confusing. Yeah, generally, when you think of a noise blanker, you're talking about like ignition noise in a vehicle, or if you happen to be, getting some noise from like a motor that runs at a constant speed, within, close to your shack. But what they mean by impulse is that it's not a continuous type of thing. It's more of a pop, 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 pop type of noise that's coming in.
Okay.
Yeah, that is a little confusing, because it can improve the performance on wideband noise, but it can help remove some of those signals that are coming in.
Okay.
Yeah, I agree. That is fairly confusing.
Discrete signals, not continuous signals.
Correct. Yes.
Yeah. Okay. How can conducted and radiated noise by an automobile alternator be suppressed? And you connect the radio's power leads directly to the battery and install coax capacitors in line with the alternator leads. How can radio frequency interference from an AC motor be suppressed? By installing a brute force AC line filter in series with motor leads. What is one type of electrical interference that might be caused by a nearby personal computer?
Can we go back to that E4, E05? Is that limited to a motor size? I mean, if you get a big motor, not the radio, the one below this, E05.
This one?
That little filter to put it on a motor. You can't, it doesn't look like you can put on too big of a motor because I don't think it handle the current in there.
Yeah, I mean, they do make AC line filters that can handle quite a bit of amperage. Obviously, if you've got something, really, really big, you might not be able to find something, but I would say most things that you would find in a regular house, it should be able to find something to address that.
Only thing I would think that maybe not able to address would be the air conditioning unit in a house. It may be, the amperage may be 30 amps or something. And that little box there, I don't know if they have one that can handle 30 amps. I agree with you on like little vent fans in the bathroom and that kind of stuff, or ceiling fans. But I don't think they're going to handle an air conditioning compressor.
Yeah, I'll be honest, I've never looked up to see how large of a current capacity can be handled by those. That might be a good thing to look up.
Okay, let's see. Where did we do I think we did this one.
Yes.
Okay. Which of the following can cause shielded cables to radiate or receive interference? And that is common mode currents on the shield and conductors. And what current flows equally on all conductors of an unshielded multi-conductor cable? And it's the same thing, common mode current. Current that's not opposed. What undesirable effect can occur when using an IF noise blanker? Nearby signals may appear to be excessively wide, even if they meet emission standards. So it's a distortion thing, is that right?
Yes.
Okay.
Now you'll end up getting distortion, and it's mostly due to the way that an IF noise blanker works. It's got to look across a wide bandwidth, and when you narrow the bandwidth, it isn't quite as effective.
Okay. What might be the cause of a loud roaring or buzzing AC line interference that comes and goes at intervals? And it's all of these choices are correct. I think there's 3 in this section that are, you can choose all of the above, and they're all of the above.
Okay.
Arcing contacts in a thermostatically controlled device, a defective doorbell in your horrible neighbor's house, and a malfunctioning illuminated advertising display. Are they implying a wireless doorbell, or can it be a wired doorbell as well?
I think they're mostly, talking about a wired doorbell.
I think they probably talking about the transformer you use to load that voltage from 120 to 24 volts is what causes that AC interference
Okay.
or buzzing.
Yeah.
What could cause local AM broadcast band signals to combine to generate spurious signals in the MF or HF bands? And that is nearby corroded metal joints are mixing and re-radiating the broadcast signals. And that's it.
All right.
So I'll stop sharing.
Okay, let's go ahead and go through and do that test section. I'm gonna go ahead and share my screen out. All right, everybody able to see that?
Mhm.
Okay, so let's go E4A. So which of the following limits the highest frequency signal that can be accurately displayed on the digital oscilloscope?
It's B.
Sample.
Yeah, never mind about the whole, it's always all of these or all of the above.
Okay.
Yeah,
Yeah, I wanted to, let's see.
B.
I wanted to show you guys, this is my handheld digital oscilloscope. It'll go up to 60 megahertz. Picked this up for, a Christmas present a couple of years ago. So sampling rate. Which of the following parameters does a spectrum analyzer display on the vertical and horizontal axes? So that's going to be RF amplitude, which is going to be the y-axis, and frequency on the x-axis.
use that to tune an antenna.
You can, it generally a spectrum analyzer, it's more like you're looking across a range of frequencies versus like with an antenna tuner, it's going to sample at different points to go back and calculate your SWR. Okay, which of the following test instruments is used to display spurious signals and or intermodulation distortion products generated by an SSB transmitter?
B.
Yeah, that's gonna be a spectrum analyzer. How is the compensation of an oscilloscope probe typically adjusted?
B.
Yeah,
B.
that's gonna be B. What is the purpose of a prescaler function on a frequency counter?
B again.
Yeah, B again. So divide that frequency so a low frequency counter can display it. What is the effect of aliasing on a digital oscilloscope caused by setting the time base too slow?
D.
Yeah, D, we're gonna have a jittery signal. Which of the following is an advantage of using an antenna analyzer compared to an SWR bridge to measure antenna SWR?
A. Oh, wait,
B, huh?
sorry. C.
C. It produces its own RF
Frequency, yeah.
signal. Which of the following measures SWR?
Antenna analyzer,
Yeah,
A.
that's going to be your
B.
antenna analyzer.
yeah.
Which of the following is good practice when using an oscilloscope probe?
Keep the ground
Hey,
connection
keep all
short.
the
A.
signals ground and connection to probe is short.
Yeah, A. Which of the following displays multiple digital signal states simultaneously?
That's A.
A.
Yeah, that's going to be a logic analyzer. How should an antenna analyzer be connected when measuring antenna resonance and feed point impedance?
C,
C.
correct.
It's going to be C. Okay. Next section. Which of the following factors most affects the accuracy of a frequency counter?
C.
C.
C? Yeah, time-based accuracy. What is the significance of a voltmeter sensitivity expressed in ohms per volt?
C.
D?
No, C, Charlie.
C.
C. Yeah. Which S parameter is equivalent to forward gain?
A.
Yeah, I believe it's S21. Which S parameter represents input port return loss or reflection coefficient?
C.
S11.
C?
Yeah.
Yeah. What three test loads are used to calibrate an RF vector network analyzer?
A.
Yeah, that's going to be A. And let me show you guys what, a network analyzer looks like. This is my Nano VNA version 2. It's got N connectors on the top, and if I turn it on, you can see it's displaying a Smith chart. So these don't have the full set of connectors on it. They only have S12 and S11 on them.
Seeing it? I don't see it, Chris. Are you showing it, your analyzer to us?
Yeah,
I don't see it.
let me see. Did I?
Raise it up just a little bit.
How's that?
I still don't see it.
There you go.
Does everybody else see it?
Yeah.
Must be my thing, my computer.
Okay. And it came with the 3 test loads: short circuit, open circuit, and 50 ohms. How much power is being absorbed by the load when a directional power meter connected between a transmitter and a terminating load reads 100 watts forward power and 25 watts reflected power?
A.
A.
Yeah, 75 watts. What do the subscripts of S parameters represent?
D.
D.
D, yeah, the ports where the measurements are made. Which of the following can be used to measure the Q of a series tuned circuit?
B.
B. Yeah, remember that the Q is a value of how wide that is. So by able to look at the frequency spectrum, you're able to go ahead and determine the Q. What is indicated if the current reading of an RF ammeter placed in series with the antenna feed line of a transmitter increases as the transmitter is tuned to resonance.
C.
Yeah, that means you're going to have more power going into the antenna. Which of the following methods measures intermodulation distortion in a single sideband transmitter?
That could be A.
A.
Yeah. Yeah, they're audio frequency and they're non-related. Which of the following can be measured with a vector network analyzer?
That's all the above.
Yeah, that's all the above. Okay. What is an effect of excessive phase noise in a receiver's local oscillator?
B.
You know, it's going to combine with strong signals on nearby frequencies to generate interference. Which of the following receiver circuits can be effective in eliminating interference from strong out-of-band signals?
D. Delta.
Yeah, a front-end filter or a pre-selector. A pre-selector is like a bandpass filter that only allows a certain range of frequencies through, and it can help eliminate interference from stronger signals. What is the term for the suppression in an FM receiver of one signal by another stronger signal on the same frequency?
C.
Yeah, C, capture effect. This is one of the reasons why aircraft still use AM. You know, there's that fear that one plane may have a stronger signal than another, and it will, you know, the stronger signal will actually completely block out the weaker signal, and that becomes a safety concern. What is the noise figure of a receiver?
C.
Yeah, that's going to be the self-generated noise. What does a receiver noise floor of negative 174 dBm represent?
C again.
Yeah, that's going to be C again. Room temperature, which they say 62 degrees. I can't afford that. Not during the summer. A CW receiver with the automatic gain control off has an equivalent input noise power density of a negative 174 dBm per hertz. What would be the level of an unmodulated carrier input to this receiver that would yield an audio output signal noise ratio of 0 dB in a 400 hertz noise bandwidth? Okay, so remember this one, it's going to be 10 log over the ratio of the frequency. And I believe that comes out to 20.
A.
Yeah, so it's like 26 or something like that.
Yeah.
So you add them together and negative 148. What does the MDS of a receiver represent?
B.
Yeah, B, that's going to be the minimum discernible signal. An SDR receiver is overloaded when input signals exceed what level?
The reference voltage.
Yeah, the reference voltage. If you've got an IC 7300 and you happen to have another hand that lives nearby, which I do, periodically I'll see the overflow indicator flicker when he's transmitting. I can be on a completely different band, but that signal's still coming into the antenna, and it can still overload the analog to digital converter in the radio. So which of the following choices is a good reason for selecting a high frequency for the design of the IF and a super heterodyne HF or VHF communications receiver?
B, Bravo.
Yeah, it's going to be B, Bravo. By picking a higher frequency, the image responses will most likely be outside of the band that you're trying to operate on. What is an advantage of having a variety of receiver IF bandwidths from which to select?
A.
A.
Yeah, that's going to be A. Why can an attenuator be used to reduce receiver overload on the lower frequency HF bands with little or no impact on signal to noise ratio?
C.
What are we thinking on this one?
I'm thinking C,
Atmospheric
but I'm not
noise.
positive.
Yeah, C. The atmospheric noise is going to be greater than the internally generated noise, even after the attenuation. Which of the following has the largest effect on an SDR receiver's dynamic range?
D.
Yeah, that's going to be D. The more bits that the analog to digital converter has, the better dynamic range you're going to get. How does a narrowband roofing filter affect receiver performance?
C.
Yeah, C. What transmit frequency might generate an image response signal in a receiver tuned to 14.3 megahertz and that uses a 455 kilohertz IF frequency?
I remember this damn question. It's C.
Yeah, that's going to be C. The base frequency plus 2 times the IF. What is reciprocal mixing?
I'm going to go on a limb and go B.
I think it, I
B,
was gonna
you
say
sure
C.
about
I'm
that?
totally, no, I'm really not too sure.
I just gave the presentation. And I don't remember. I think it's C.
It's going to be C.
Yeah, that's it. C, that's what I meant.
Okay. 2 more sections. What is meant by the blocking dynamic range of a receiver?
A.
Yeah, it's going to be A. Which of the following describes problems caused by poor dynamic range in a receiver?
Matt, I'm going with B. You think?
Yeah, B.
Matt's not listening to me.
How can intermodulation interference between two repeaters occur?
It doesn't have anything to do with airplanes.
Okay, so they're going to be in
No,
close
they're B.
proximity,
Yeah, I think it's B.
and they're going to mix in the final amplifier. Which of the following may reduce or eliminate intermodulation interference in a repeater caused by another transmitter operating in close proximity? Do you remember, this is that device that acts like a one-way valve.
Yeah, the circulator.
Yeah, the circulator. What transmitter frequencies would cause an intermodulation product signal in a receiver tuned to 146.7 megahertz when a nearby station transmits on 146.52 megahertz? Remember, this is the one that George rewrote up the formulas for.
If I had a calculator handy, I could figure it out. I just didn't memorize the numbers.
So it's
Yeah,
going to
me
be
too.
2 times the first minus the second, or 2 times the second minus the first. And I'm going to fire up my calculator. So 146.7 times 2 minus 146.52. So 146.88 is going to be one of the answers. And that only occurs. Okay.
I think the issue was that the formula you're referencing is equal to F mod, which is 146.7. Did you put that on the left-hand side of the equation?
Okay. Yeah, let's see. Let me try 146.52 times 2 minus 146.7. 146.34. There we go.
146.34. Yeah.
Yeah.
that's-
What is the term for spurious signals generated by the combination of 2 or more signals in a nonlinear device or circuit?
Intermodulation.
Yeah, that's going to be intermodulation. D. Which of the following reduces the likelihood of receiver desensitization?
C? Is it C?
C. Yes. What causes intermodulation in an electronic circuit?
That is A.
Yeah, nonlinear circuits or devices. What is the purpose of the pre-selector in a communications receiver?
A.
You know, a pre-selector is like a pre-filter. So it's going to help reject the signals outside of the desired band. What does a third order intercept level of 40 dBm mean with respect to receiver performance?
That's going to be B.
Yeah. B. Why are odd order intermodulation products created within a receiver of particular interest compared to other products?
A.
It's gonna be A. What is the term for the reduction in receiver sensitivity caused by a strong signal near the received frequency?
That'd be A as well.
A? Yeah,
Yeah.
desensitization. Okay. Last section. What problem can occur when using an automatic notch filter to remove interfering carriers while receiving CW signals?
Oh, C.
Yeah. Yeah, it'll notch out the CW signal as well as the interference. Which of the following types of noise can often be reduced with a digital signal processing noise filter?
All the above.
Yeah, all the above. Which of the following signals might a receiver noise blanker be able to remove from desired signals? This is the controversial one.
Yeah, the wide bandwidth.
Yeah, the wide bandwidth. How can conducted and radiated noise caused by an automobile alternator be suppressed?
B.
Yeah, that's gonna be B. How can radio frequency interference from an AC motor be suppressed?
Going D.
D, yeah, an AC line filter. What is one type of electrical interference that might be caused by a nearby personal computer?
That one's A.
A. Which of the following can cause shielded cables to radiate or receive interference?
Common mode current.
Yeah, common mode. What current flows equally on all conductors of an unshielded multi-conductor cable?
D.
Yeah,
That's
same
going to be
thing.
common mode. What undesirable effect can occur when using an IF noise blanker?
That's A.
Yeah, A. What might be the cause of a loud roaring or buzzing AC line interference that comes and goes at intervals?
All the above.
A.
All the above.
B.
What could cause local AM broadcast band signals to combine to generate spurious signals in the MF or HF bands?
That's C.
Yeah, that's going to be C. The corroded joints start to act like diodes. All right. Good job, everybody. I'm going to go ahead and, well, before I stop recording, did anybody have any questions? Okay, well, I'm going to go ahead and stop.